We should be live.
Yay.
Yeah.
Live is good.
Trick is I'm super smooth at this now. What happens when you do something like 1,000 times is
Yeah.
you 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 get a little experience doing it. So,
Just a little.
um, hey Pamela,
Hi. How are you?
I got a new microphone.
Yay. What did you get? Oh, did you get a Yeti Black?
No, I'm done with fancy pantsy USB microphones. I'm going old school. So I got this microphone, which is it's not a super fancy one. I wanted to sort of test this out. There's a much fancier microphone that I want to get my hands on. This is a Art D7, but it's a large diaphragm dynamic microphone. So it's specifically a voicey podcasting microphone.
Cool.
I've also got a compressor, so my audio goes. Oh, Dane is hearing some buzzing.
I don't think it's me.
No, maybe me. I don't know. Just as I mentioned that I got a new microphone, Dane is saying that I got hearing some microphone buzz. So we'll see. Anyway, I got a compressor, and it goes into my preamp or my interface into my computer, and then it comes in. No, nobody told me that my microphone has a buzz. Does it have a buzz?
Okay, let me mute myself.
A couple
and
of people
see
are
if
saying they
it's-
heard a buzz. Okay. No, no buzzing. Some people are hearing buzzing, other people aren't. I'm peaking a bit. All right. Let me turn down the output one notch. Here, Carly, you don't hear that? Okay, I'm going to go one.
I love my super fancy pants microphone.
I like it too. Okay, hold on.
And it looks like you're starting to have a fancy pants arm like mine.
No, it's the same one. Okay,
No?
yep, buzzing.
Okay.
Okay, hold on, everybody. I'm gonna try bringing the gain down one notch. There. So I take the gain down. Okay, listen. More buzz. Now that I turn the gain down. Okay, no problem. I'm gonna turn down the output. So now it's outputting at a lower level. Loads of buzz. All right.
Okay, I'm going to mute.
I'm gonna go
just
back to the settings that I had
double-check.
before, and it buzzes when I move. Possibly more buzzing. Okay. I will turn down this guy a little bit. Just a little bit. All right. Well, I figured there's going to be some more technology that I'm going to have to mess with. So, yeah, analog now like a savage. Just not in the low frequencies as much. Do you have a notification turned on YouTube? Yeah. All right. More like a hum. Well, I do have my faded when I lean down. That's interesting. Okay. So maybe there's some
Crosstalk with your
some
headphones?
crosstalk with the yeah. Okay.
Do you
all right.
have better shielded headphones?
That's not this head. I love that max 6 blade. That's not the settings. It's 60 hertz. That's interesting. Okay. I'll have to. Could be a transformer near the mic. Do this. Boop. Move these guys apart. Yeah, I love. We got a bunch of audio engineers there in the watching the show. Anyway, I knew that this would be the case. I knew that this was going to be a whole new kind of challenge, but this is the challenge I have to go through. The problem that we have is that I don't have a it's my sweater. No.
It could be if
Yep.
you have static.
Yeah. Yeah. I'm sure I do. I'm sure I do. It's my
But there's
little-
volcanoes erupting according to the chat.
Oh, really?
Yeah, Nancy just posted a bit of current events related to Astronomy Cast 440. Destroy and rebuild supervolcanoes. New York Times just posted Mount Etna erupts in Sicily, injuring at least 10.
Oh. How do you feel?
Oh, this is the one that happened a couple weeks ago. Yeah, so there were people like right next to the crater. Don't do that. That's dumb.
Yeah.
So they're right next to the crater and it starts like going off. And so they ended up running down the side of the volcano as rocks are shooting out at them. Yeah, don't stand on the side of a crater. I consider that Darwinian.
How do you feel about the your enthusiasm for devastation now, Pamela?
Hey, this is Darwin in action. If you're going to stand on the side of a volcano
Yeah.
that is an active volcano, you know.
Yep. Yeah, I can definitely see like a backgroundy noise. It's a 60 hertz buzz. This is so funny that people are actually figuring out exactly what it is.
Do you have fluorescent lights?
Yeah, I got all kinds of things. There's an absolute mess of cables, so I'm sure there's some crosstalk going on. But we will. Let me try.
You isolate your
untangle
audio
these.
cable. The audio cable crosses nothing.
Really? In your world?
Yeah.
Hold on. Gonna lose the audio for 1 second.
I now have, because you said it's a whole new world, I now have the song It's a Whole New World stuck in my head from Aladdin, and I need to share this brainworm with our entire audience.
Okay. Back again. Let's see if I'm. Come on with you. Yeah, okay. All right. Yeah, mess of cables. There you go. Buzz free. There you go. Oh my god.
Don't cross the stream.
Don't cross the streams. Clearly that's what it is don't cross the streams. All right. Okay, good. Oh, good. All right. That's horrifying. And now it's back.
Know this? Seriously?
Yeah. That fixed it. That didn't help. Good. Well, I'm glad we can agree. And Pam sounds great. Right, because she's got her fancy USB microphone.
It's not a USB.
That's interesting that it was gone. And oh, you know why it was gone? It was gone because I disconnected my audio interface. So.
Oh. Yeah. And I have a preamp. It's not a USB microphone.
Yeah. It's back. When he went away, the mic didn't catch anymore. It went off. Yeah, because I unplugged myself from the. You hear the buzz, but it's quieter now. Okay, all right. This chat is conflicted. Yeah, the chat is tough. I'm gonna turn down the gain. Well, you tell me. Okay, we got one last thing. Thanks everybody for helping me figure this out. I'm gonna turn off the 20 decibel gain, and let me know if that helps. So now I've got less the 20 decibel gain, but I think it just makes it quieter.
You're a lot quieter.
Yeah. But whether the buzzing goes away, and you don't hear any buzzing though from your end.
I'm slightly hard of hearing. I am the wrong person.
Really?
Yeah.
Interesting. But now, it's the same. So people are saying it's fine, and other people say it's the same. I don't know. And there's the gain back. I'll turn down the gain one notch. See what happens. And I will sit and figure this out over the weekend, and we'll go from there. All right. That's worse. Buzz is the same, you're quieter. Interesting. So the buzz, that's fascinating. What if I... Something is trying to add more volume. I think I know where it's coming from. All right. Last try. And then I promise that we'll wrap this up and do an actual episode. But if I had I can turn down the gain on that, and then turn it up over here. Yeah, it's the cosmic microwave background radiation.
Well, I'm sure that's part of it. It's just, can we?
Yeah,
I don't think the CMB is at 60 hertz.
Yeah. And try turning my lights out. That's interesting. So that got worse. Man. When I leaned down, the buzz got louder. Lower gain makes the buzz worse. Turn it up to 11. That's awesome.
I love all the randomness we're inserting.
Yeah, totally. Because I can see, I tried to sort of see it visually, but there's a problem with that. Oh. See, so someone said the buzz is gone, and then someone said that helped.
I wonder if they have different amounts of lag.
Now gone. Really? Buzz gone because I'm holding them in my hands. Huh. And then if I put them on the ground... There. Now I'm not. So it's shielding my connection. So there's some kind of interference. Yeah, I'm just going to hold two... the two devices for the entire episode. Yeah. We'll see what happens. Well, hey, thanks everybody for this wildly entertaining episode of Astronomy Cast. This is just delightful. This is exactly what I think you all want to see. And this is gonna be even more hilarious when I mention sort of a new thing that we have for you. Oh yeah, that's way better. I can actually see in the audio track that it's way, way better. All right. Definitely a ground loop. So should I just touch it with my foot? Should I just
It might help.
Yeah. There we go.
You have like your little sock foot on top of your wires now.
Yeah, exactly. We're just going to cut all that out. This will never happen. Oh, thank you, fans.
We love all of you.
So one, of course, I mentioned this over back in the Weekly Space Hangout before we did that show. National Geographic. Here, I'll go to my... Yeah.
I saw this on your Instagram earlier today. This was hilarious.
There you go, National Geographic. Thanks for sending me this box. Hey, everybody. April 25th. April 25th. It's going to be the Einstein Genius Show. And normally... I understand I'm like some kind of influencer, but you can't, I understand that they're going to send this out and they want me to mention it, but like they're doing a scripted show about a scientist. I'm all for that. Right? I'm 100% on board with that idea. So we can't go wrong with that.
As long as they fact check. You can go terribly wrong with that, but I'm going to assume Nat Geo won't.
Yeah. Well, did you ever see the Einstein and Eddington series?
The David Tennant and that was someone in our audience, I wish I could remember their name, mailed it to me because I couldn't figure out where to get it.
Yeah.
So thank you, person whose name I sadly can't remember right now.
Oh God. All right.
Are you okay?
I am fine. I'm fine. I had the best time, had the best trip down the West Coast, and that's one of the reasons why we weren't able to record last week. Hung out, visited Patreon, visited YouTube. It was a super good time. Met with Amy Shearer Tidal and Ian O'Neill, and hanging with David Joseph Wesley and Kevin Gill, who is now working at NASA. We had a great time. But clearly, like literally 1 week of, or 2 weeks of being away from this job, it's just like, so guess what I didn't write?
The intro.
The intro. So, here you go.
Okay, while you're writing the intro, I'm going to see if I have water. I do need to heat water.
Why don't you tell people something? Answer some questions. Hey, everybody, ask Pamela some questions.
Okay, Larry Beckham is seeing Copenhagen in London. Questions. Hi. I'm going to point out that there's a portal to an alternate universe in my bookcase, otherwise known as where my basil is growing, just in case anyone is curious as to why my bookcase is glowing. I don't know how to ad-lib. It's a rainy, failing to be spring day here in Illinois, and we're going to discuss fractals once
sad.
we can get all of our stuff together. So I just got back from being at Penn State for 4 days. So I think the two of us coming back from travel means scattered brains everywhere. Several people are typing. This is exciting. And for people who are in the YouTube chat, which I don't have open anywhere because bad internet connection, the chat that I'm looking at is the Weekly Space Hangout chat, which I think is actually beneath me in our live stream. And you too can join the Weekly Space Hangout crew. I'm sure the folks will add the link so that you can see it in a moment. Ooh, we have questions. See any images from the Clark belt? No, I haven't. What can a lot of magnetism do to space? Like a lot of gravity makes a black hole. So magnetism comes in both positive and negative. So assuming that you have a randomized distribution of poles, it all will eventually like zero. Gravity is special because it's always attractive. Magnetism, it likes to be oriented in specific ways, and that's okay. Any tornadoes touchdown?
That's enough. We're ready.
Okay.
Any tornadoes touchdown? Actually, I want to know that too. Did any tornadoes touch down?
Not recently. And I'm going to mute so I can pour water without it sounding gross.
Okay. So we're going to talk about microphone, full feed, and
we're not going to talk about microphones at full feed. We're going to talk about fractals.
Well, no, in the intro bit. Man, we got some things we got to do. All right. The full feed is super cool, and you'll all get the horrible irony in a second here. All right, are you ready?
Yeah.
Okay, I'm gonna press record.
I am pressing record as well, and it is recording. Hello, Chad. We adore you, Chad. We hopefully won't torture you. But Fraser has a new mic.
I have a new microphone, so it's all new forms of torture. But I could actually see that background hum, and now I don't see it, so everything is good. All right, let's do this thing. Astronomy Cast, episode 444, Fractals. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Wrestling with technology. So for those of you listening, I am using a new microphone. Please, those audio files out there, let me know how it sounds from your end, and I will glad to hear your feedback. That's the first thing. I got 3 things to say. So the second thing, and this is I think pretty exciting, is that we've added a whole new show, which is called the Full Feed. And what this is, for those of you who don't know, when we record Astronomy Cast once a week on Fridays at 1:30 live, and
Pacific time zone.
Pacific time, and the show goes for actually an hour. And you listening to the podcast right now, you're only getting half of it, There's a whole section where we wrestle with technology. And there's a whole part afterwards where we answer the questions live with the audience and get into some really interesting sounds. And I really enjoy it. And I think, just between you and me, I think that live part of the show, the part afterwards where it's all just, we're just interacting with the fans and just talking about whatever's happening in space exploration and things like that, it's really entertaining. So you should switch if that's what you want. If that's the experience you want. I can understand you can't show up live for the regular show, but if you want to be a part of the, if you want to hear it while you're doing a run or whatever, you can find it. And let me just find the exact link to make sure I get this right. So go to astronomycast.com/feed/full raw and go ahead. And that is every part of the show. And ironically, this episode, we just wrestled with my microphone for the first 10 minutes. So other times it's going to sound much better, but for now, this episode specifically, not our strongest opening. But I hope the final part is going to be way better. All right, you ready, Pamela?
I certainly hope I am.
All right, so for this historic 444th episode of Astronomy Cast, we talk about fractals, those amazing mathematical visualizations of recursive algorithms, and those tasty broccolis. So what are they? How do you get them? Why are they important? All right, Pamela. Now you threw this one in. You're a bit of a fractal fan, aren't you?
Well, it's more a matter of, it was unbeknownst to, I'm guessing, most people out there listening, the natural way to conclude our Death and Destruction series. Because it turns out that a lot of really cool death and destruction related things have a fractal nature. So, for instance, fault lines are fractal in nature. Coastlines that have suffered from landslides and lots of other destructive things, fractal in nature. And hey, it seemed like a good way to celebrate it being fours all the way down, and to maybe start to transition to talking about some things that aren't quite death and destruction.
Right. So I guess what identifies something as a fractal? So how do you get, we've all seen these kind of Mandelbrot pictures of like blobbies, and when you zoom in, they're the same, they're kind of recursive, but like, what is the gist of this?
So, what's fun about trying to look up what is the best way that I can describe fractals without inadvertently offending a mathematician, because here's where I have to admit, I would much rather write software to do maths for me than actually do maths.
And last time we did a show on infinity and got no end of grief from the mathematician. So we're going to go light on the math.
Well, and what was awesome in trying to look up how to best describe this accurately was I kept finding articles that say mathematicians can't agree on a mathematical definition of what a fractal is.
Ha!
And yeah.
Well, then we'll just live in the middle there.
So it boils down to a few key ideas. So first of all, fractals are self-similar at scale after scale after scale. This means that as you look at them at more and more detail, what you're seeing doesn't actually change. So like human beings, we are not fractals. If you zoom in on a human being, you're going to go from seeing human body to seeing body part to seeing skin, hopefully, to seeing individual cells, to maybe seeing like a cell, to looking in the scale. It is not fractal. It is a different thing at every zoom. But when you start looking at things that are fractal in nature, snowflakes being one of the ones that we all try and make as small children, when you look at them at more and more detail, every time you zoom in, it's like, wait, the view didn't change. No, it didn't. It's fractal.
Okay. And so how do you get a fractal?
So it's simply a matter of something that is the same at pretty much all scales and is complicated. So like lots of things aren't sufficiently complicated to be called a fractal. So the way you get them is you have a detailed, complex system that is irregular in ways that is repetitive and scales. So one of the simplest ones to try and understand is what's called a coach snowflake. This is where you take a regular happy equilateral triangle, and then on each of those three sides, you divide it into bits and add an equilateral bit. So you now have on each side of the triangle, it now becomes a triangle bit, another triangle bit, and they're all the same. And then you take each of their edges and you split it into thirds again. And you keep adding these equilateral triangle bits. And as it gets added and added, the edges get more and more complex. But when you zoom in on these edges, they look absolutely identical at all scales.
What is the point?
um, well, so what is fascinating is it started kind of as a mathematician crossed philosopher thinking hard. And so when you start looking at the history of fractals, it goes back to the 17th century, where you had people thinking about the little voice in your head, the homunculus, and how that voice in your head had a voice in its head, had a voice in its head, and its little men in the head all the way down. And so it started with this idea of recursion. And then it moved from being a philosophical, mathematical concept to people starting to play with, as calculus began to be a thing, are there lines that refuse to be what's called differentiated, which is a way in calculus that you can approach a line and start to figure out what is the area beneath the line, what is the inflection point. There's all sorts of cool mathematical things that you can do if you can differentiate something, but not all lines can be differentiated. And fractals are just like, nope, not going to do it. Because since there's not really anywhere that you can like line across a fractal, because they're constantly bending and twisting and turning, and so they're undifferentiable. And so people are like, let's define all the lines that have this characteristic. And from there, people started to think about, well, now that we're finding all of these lines that are complex, recursive, not differentiable, are there any things about them that are consistent? And it turns out that the way that fractals scale over size, they end up with different fractal numbers. So a way to think about this is, normally you have something that has a length. If you want to look at its area, that scales by the square factor of 2. If you want to figure out what the volume of that thing, taking it into 3 dimensions, is, then you have to take that factor of 2 and raise it to the 3rd power. So the volume is 2 times 2 times 2. So you have this nice linear way of, with an integer, going from line to surface to volume. Fractals are like, nope, not going to behave. Fractals, as you look at increasing dimensionality, they don't go as an integer, they go as a fraction. Fractal, fraction, it's what they do. And different things have a specific scaling factor. And this is cropped up in things like, you can look at Jackson Pollock paintings, and all of his paintings have the same fractal number. And they've identified forgeries because the forgeries had a different fractal number. Because Jackson Pollock paintings are basically splotches of paint at all different scales. And when you start looking at how does it change as a function of scale, that change, that's its fractal number.
And I mean, sort of the perfect fractal, there is no difference. It's almost like, I don't know, it feels like it's like the scale of the universe or something like that, right? Like at a certain point with the universe, as you scale out, you start to get to that cosmic web of galaxies, and as you go further out and further out, then you're just seeing larger and larger. But that's actually not true. There actually
No,
is a,
universe isn't actually
yeah, the
fractal.
universe
That's
isn't
one of those
fractal.
things.
Yeah.
People kept thinking universe must be fractal. No, it's not.
Right, right. And that it actually does have a maximum scale, that you move out to a certain point and you've got these cosmic webs, these columns and walls and of galaxies and voids in between them, like, I don't know, like some kind of tasty chocolate bar. But then you go further out and there's no larger version of that pattern. It's done. So but with a true fractal, you kind of can't, when you look at it, you really don't know how far you've zoomed in.
And what is kind of awesome is how this can be applied to understanding how different systems have the potential to build up inside themselves, which is one of those really hard things to explain. So I'm going to back out a little bit. If you look at a coastline, you might casually say that the California coastline is like 1,000 miles long. And that's simply you draw a line up at the border between California and Oregon, keep it going down, draw a line that ends when you get to the point where California meets Mexico. Cool, nice, straight line. Well, coast isn't actually a straight line. So let's approximate it with a nice simple curve with one inflection point. That's now longer. But, you have bays. You have like Long Beach, San Francisco, all of these different places where you can take a ship in and get into safe harbor. So you start adding inflection points. But then you start realizing, wait, there's deltas, and there's really no end to how long the coastline is, because as you measure at a greater and greater fine scaled measurement, you keep notching your tape measure up more and more. And at a certain point, California has an infinitely long coastline. And that's part of the fractal nature of coastlines. And fractals in general don't have a length, which is kind of cool to think about, because every time you zoom in further, you find smaller and smaller line segments,
Whoa.
smaller and smaller curve segments.
That just blew my mind. Okay, hold on a second. So if you take like some kind of little loop-de-loop shape, like a roller coaster or whatever, and you follow the length of the roller coaster, you're going to get some kind of length. And if you zoom in, then you're going to start to see little bumpies on the rails, and that's going to actually increase the length of the roller coaster. But at a certain point,
roller coasters are not fractals.
Well, no, I understand.
Just
and this
for
is
anyone
the point.
in the audience
Right.
being confused.
No, but this is my point, right? Which
Yeah.
is that you could zoom in on a roller coaster and you could get a little bit of a longer pathway, because you're actually you're kind of following the bumps along the actual rail that the roller coaster runs on. And so it's going to be longer, right? But then at a certain point, there's going to be some maximum where you're literally hitting the length of the atoms, and at that point, there's no possible longer version of the roller coaster. But in the case of a fractal, if you're following along that line, and you calculate the length of that line at whatever rough resolution you're looking at, and then you zoom in a bit more, you're going to see a longer line, and you're going to zoom in a bit more, and you're going to see a longer line, and more and more and more. And that goes on forever. It's like that idea, but obviously, these things don't exist in the real world in that way. It's that they're a mathematical representation, right?
But things like coastlines, it's really kind of amazing to think when you're saying how long a nation's boundary is, how long a coastline is, you really have to say averaged over 5 kilometer long segments
Yeah.
to start to make sense of this. And if you've ever flown over the deserty bits of the American Southwest and the canyon lands, you'll notice that the places where water runs down out of the mountains, rivers have this amazing branching structure where they just seem to branch and branch and branch as you get further and further from the main body of the river. And that branching structure is actually also fractal in nature, where as you go down to just the single sand dune with all of the droplets of water running down it, you keep getting a finer grade fractal structure. Now here you are going to start to get limited by the size of a sand grain and the size of droplet of water.
Right.
But the nature of this is fractal in nature.
And that if you looked at the river system of, say, the entire United States, and then you looked at the river system for the final kilometer of a river going into the ocean, and you looked at a meter of a little piece of a little rivulet that's coming off the side of that river, you're going to end up with almost precisely the same structure. It's just a matter of scale.
And it's in trying to figure out how to mathematically describe these things that fractals become so powerful, because the fact that there is this non-integer scaling factor that allows you to go from one zoom level to the next, that non-integer number is actually unique to different situations, where you'll see a different fractal number depending on what the landscape the river is passing through is.
Yeah.
We find different fractal numbers for different fault lines, but across the fault line, that fractal number, as long as the landscape stays consistent, that fractal number stays consistent.
And we really needed computers, right? I mean, this is a mathematical field of study that really required computers to explore fully, because a computer doesn't mind calculating the same math 4 bajillion times again and again and again, right?
And with computers, fractals actually became extremely important for animators and people who are trying to generate landscapes, because you need to look at how does something look the same or different at a variety of different scales. So in your video game, when you're generating the coastline, when you're generating hair, for instance, because at one scale you see individual strands, at another you see chunks, at another you see the whole dang ponytail. And at a certain level, we fully realize this because of how we draw cartoons, how we paint paintings. But when it starts to be how do we visualize things, the fractal nature starts to come into play.
Very cool. Now, do you have a favorite fractal?
I love the idea of coastlines. And part of the reason I love it is I grew up in New England, where it was always people making fun of New Hampshire for its lack of coastline. It was like, New Hampshire, what's wrong with you? Do you not like the ocean?
Yeah.
And then you get into New Hampshire's filled with lakes. So does it actually have more waterfront when you start taking into account lakes? But then you not only have to do that, but you also start arguing over, well, do you take into consideration all of the little coves and all of that? And it's a fun argument that brings fractals kind of to life.
I have a similar situation, which is that, as many of you know, I grew up on a small island off the west coast of Canada called Hornby Island. Go ahead, Google it. And the island itself is maybe 5 kilometers across, maybe smaller, and so we could go anywhere. And one summer, my friends and I decided that we were going to walk around the entire coast, just walk on the beach and fully circumnavigate the island. And we knew that it was actually we'd heard some other people had done it, a lot of work. And so we got up, I think we started at 3 a.m, and walked until about 10 o'clock at night and didn't quite reach our starting point even after that entire day. And yet, we knew all of these beaches. We'd been on all of them many times before, as throughout our lives. But that curving back and forth, the following the exact contour of the beach line, was a much bigger, more complicated job than we thought it was going to be.
And this starts to come into play when you think about, why do apartment buildings have such bizarre footprints? Well, it's because everybody wants windows, and they want as many windows as possible.
Yeah.
And so you start having that fractal nature to the outside of your building. You start with a cross, and then you turn it into 4 T's, and then maybe you start adding things sticking out. It's a way of maximizing surface area by volume.
Yeah. Super, super interesting. So, you've talked about coastlines, you've talked about rivers. Are there other fields of mathematics, other fields? Is there any connection to cosmology? We talked about how there literally is, specifically the large scale structure, it's the opposite. And that for a while there was something that they even maybe anticipated. There would be some kind of larger scale version. Where are some other applications of fractal mathematics?
So the best not on Earth example I can give you is Saturn's rings. And what's amazing with the rings is when you look at them with your friendly, handy dandy little tiny Galileo scope, which is like the cheapest, best, most awesome telescope for viewing Saturn's rings. Spend $50, view the rings. So when you look at them with that, you see a couple of gaps, but you can tell it's a series of rings. Well, if you look at it with just binoculars, it's like a ring. So you go from a ring with binoculars to a few rings with Galileo scope to, well, go find yourself a 30-inch telescope. Now you're looking at more rings. Put Cassini right next to the rings.
Yeah,
and
you found more rings.
It's rings upon rings upon rings. And the more we look at the structure, the more we see this constant breaking up into grooves and bands, and so beyond the Earth, the rings of Saturn. But here on the Earth, we find fractals in so many different places that we don't really recognize as fractals until you start trying to, well, figure out how long things are. So a lightning bolt, which branches out into all of these different bits.
Yeah.
If you zoom in more and more on that lightning, you see more and more bits and more and more bits. And lightning bolts are fractal in nature. One that I want to learn more about is apparently the texture of mountain goat horns, with the grooves on the horns has a similar nature to Saturn's rings, where it's just grooves upon grooves upon grooves. Algae often has a structure. I'm going to destroy this poor piece of broccoli's name, but Romanesco, I think is how it's sort of said. Romanesco.
Have you ever seen this? We have this in the grocery store here.
Yeah. I actually bought some seeds for it this year.
Yeah. I've got some in the fridge some seeds that we may grow. Although I find broccoli is just too much of a pain. I just buy it in the store. I'm gonna try, because my 72 seed starter thing had an extra 2 rows that I could start things in. Well, let us know if that broccoli ever makes it to the kitchen table.
I will.
My guess is it'll end up somewhere in the mouth of a
groundhog,
of a caterpillar somewhere.
Oh, well. Yeah. This is what net is for. This is what netting is for.
No. Well, we don't need to go down that rabbit hole in this episode, but I've started to build a garden inside the house. It's surprisingly pest free. Well, that's really cool. So, is this? There was this big rush of fractals back. I'm trying to think, like in the early '80s, mid '80s. I remember there was like some great scientific magazines. There was like computer programs that you could run. Are we, is it a continued field of study, or is it sort of, once the computers came on, was it sort of, did people dig through it, and now, there's less researchers working on fractals these days?
Well, I think it's less sexy than it originally was because it hits a relatively new thing. Um, the first use of the word fractal was only in 1975. So you and me, we're not that old, but we're older than
Older
the word fractal.
than the word fractal, right?
And it was one of the first things that software engineers and heck, little kids learning logo. You could learn how to write
Oh,
recursive
logo.
software and create fractals with your happy little logo turtle.
Turtle. Yes, I remember that. Oh, that's awesome. I was about to
And
say that too. It's the turtle. Yeah,
it's turtles all the way
it
down, it's
is
fractals all the way down.
turtles all the way down.
And so there's this whole it's a new idea. It's super exciting and we have technology to play with the new idea.
Are there some places that you like out on the web, on the internets, where people can look at and play with fractals? Have you been as in sort of your preparation for this episode, or are there some resources that you've encountered?
So if you Google simple things like fractal animations, fractal artwork,
Yeah.
there are amazing graphical artists out there. Just do a Google image search and it will kind of take your breath away. And I have to admit, looking at all of this, more than going, ooh, I must share this. My reaction was, ooh, I must program this.
Yeah.
So this is the kind of thing where I'm thinking processing.org, the software there. When I find a spare few hours, I'm going to be coding myself up a fractal generator.
So never. All right. Well, thanks, Pamela. I look forward to your fractals.
My pleasure.
All right. Stop.
And
Save.
now we save. And for people listening to the entire episode, here is where we bore our
Right.
live video people, and now we bore you with audio only as well.
Maybe this wasn't our best idea. No, I'm sure. People who, you know, I don't know about you. I like YouTube and all, but I just like
I'm an
YouTube.
audio person.
I need to
clean
listen
the
to it's
house while
podcasts.
listening to audio.
Yeah, it's got to be podcasts, right?
Yeah.
Yeah, you clean the house listening to audio. You drive listening to audio. You go out for walks and you've got audio, and you can't do that with YouTube.
Yeah.
And I think that's YouTube's fault. YouTube, if you're listening, allow anyone to turn any YouTube episode into a podcast. Go ahead and put audio ads in it. That'll be fine. I would like to subscribe to YouTube channels as podcasts. Until then, we're going to do the hard work for you. Man, I should tell my rep at YouTube that.
Yes, you should.
All right,
You
I will.
really should.
Where were we? Oh, right. I've saved. I can upload in a second here.
Yes.
So
we're
go
not going
ahead
to
and
upload while
post
you're
any
there.
questions that you have into the chat. What about the first reuse of the SpaceX rocket?
Oh, that was kind of cool.
Wasn't that
And what I
amazing?
loved was like, and we brought the fairing down. I don't know if they caught it safely. I haven't seen pictures of that yet. But the fact that apparently at the press conference he said, and maybe someday we'll try and get the second stage as well. It's
Yeah.
sort of like,
Yeah.
okay.
Yeah, the fairing, and I love Elon Musk said, if you had a $6 million pile of money dropping to the ground, wouldn't you try to catch it?
Yeah.
Yes, I would. Yeah. So the launch went smoothly. The rocket is. I think now they're going to use it as a museum piece. This first reused rocket. And the fairing's will have a second lease on life as well. And then, as you said, in the future upper stages, it's fantastic.
And what I'm particularly appreciating is there's like this little robot that we're all desperately waiting to see, and Elon Musk is like building anticipation about his welding robot. I don't know why, but I know that there's now probably a whole lot of us who are like, welding robot? Can we see the welding robot? We want to see the welding robot. It sounds awesome.
And our neural lace Have you heard about this?
No.
No. So this is he started another company, and what this is going to do is it's going to come up with a brain computer interface. So
Oh, yeah.
some
I did see
kind
that.
of neural lace that will get in, you'll get it implanted into your brain. It'll allow you to communicate with the cloud directly.
It feels like John Scalzi's Old Man War.
Yeah. I mean, I loved that series. I mean, they sort of.
Yeah.
Well, I don't want to give you any kind of spoilers on what happens.
Everyone, go
Go-
read, listen to
Yeah.
Old Man's War.
Yeah, it's an absolutely terrific series. The first one for sure. What else is happening? Oh, right. And then the other thing, a lot of people have been asking me about this. So have you been following at all the this idea to put an asteroid into Earth orbit and then hang a skyscraper off of it so that the skyscraper dips into the Earth's atmosphere and hangs above Earth cities?
No.
No, you haven't heard. It's called the Analemma Project or the Analemma Tower, and so that's the Analemma is the it's that's the name that the sun takes when you take a
Yeah,
picture of the
it's the
sun
path.
every day. Yeah, it's the pathway of the sun in the sky, and so the idea is there you go. You just saw a picture of it, didn't you?
New York firm wants to do this.
Well, yeah. So, and a lot of people were like, "This is so cool." They want me to do an episode on the Guide to Space about it, and I might. I'm not sure. Like on the one hand, the idea is theoretically possible, right? You bring a asteroid into Earth orbit. You then wind a cable down from the asteroid and then construct some kind of tower on the asteroid on the cable so that you've
There's
got
a
this
bit of
counterbalance.
friction involved in this.
Well, but here's the thing. This is a space elevator, right? This is how you build a space elevator. So you take a space elevator, you take an asteroid as your counterbalance, you hang a cable off the space elevator, you wind it down towards the Earth, and it eventually gets down to the Earth, and then you bolt it onto the planet. And now you've got a space elevator, right? A way to get up to geosynchronous orbit on an elevator. So this gets you 99% of the way there, but then you don't actually touch, which then loses all the advantage of a space elevator, right? Like you don't have a space elevator. You don't have an inexpensive. You have this ridiculous tower floating up in the atmosphere.
And low Earth orbit becomes useless. So I'm looking at the video, not the videos. I'm looking at the image of this, and so you have asteroid, big old asteroid in geosynchronous orbit. So first of all the weather satellites, all the communication satellites.
No, it would be a little further because it'd have to counterbalance the mass of the cable and the tower itself.
I'm guessing that the mass of an asteroid is so much greater than all the rest of that it's negligible. The sucker's the center of mass is going to be inside the asteroid.
Yes.
So that center of mass.
It depends on the mass of the asteroid. It could be a small asteroid, and then you can put it further back from geo, as long as it balances out the cable and the tower. They'd have thought of that, Pamela.
Now you've wrecked more parts of orbit, because the only part of orbit where things stay stationary over the Earth is geosync.
Is geosynchronous. Right, so you have to
going
still
faster
end
or
up.
slower.
No, you have to end up at geosynchronous. You still have to overall across the like a space, like the traditional idea of a space elevator, right? Is you start a two-sided cable at geosynchronous orbit. You spin cable one direction towards the Earth. You spin cable the other direction out into space so that it's balanced with geosynchronous being the halfway point.
So the problem is all the other stuff in orbit that's going faster or slower.
Yeah.
And we don't want to have to put fuel to maneuver around a stupid space elevator
Yeah.
that doesn't actually reach the surface of the
It doesn't
planet.
serve as a space elevator that rich people can look out the window as they move past the
Yeah.
the right. So I feel like the idea is theoretically possible, but practically, and they said like the price of it would be less than a building in Dubai or something like that, which is now ridiculous, right? Like how do you move an asteroid into geosynchronous orbit? Well, first thing you got to do is you got to find an asteroid that's the right mass. You've then got to slowly and carefully move it over a tremendous amount of time using some method of moving asteroids, which has not been figured out yet. So anyway, and then you've got to be able to have something that can handle the stresses involved. So you got to have some kind of high-tech fiber that's like carbon nanotubes that has still yet to be developed. So anyway, you can tell I'm a little frustrated here. People are super excited about it. Like CNN is covering, like everyone is covering it, right? And we're not covering it.
I
Maybe
just
we
want
are.
a Wilson Tower. Somebody just build me a Wilson Tower.
What's a Wilson Tower?
It's a 1 kilometer high tower that actually has like amazing forces that it has to withstand because of the wind speeds at different altitudes. And you have to, it's one of these things where an architect figured out scores of years ago how to build one successfully, taking all of this into account. And they've come close to building some down in the United Arab Emirates, but it hasn't been done yet. And it's just sort of like, give Wilson his tower. He figured this out like before we could computer model everything.
But there was a tower. The Japanese developed ideas for like a 10-kilometer tall tower.
Yeah.
That was like this really cool, almost looked like a pyramid with these really big structures, and there was like these. It looked like Tinker Toys kind of, and then where all the attachment points were, that's where people lived, and then everything else were these big support structures. Anyway, it was a really neat idea. Anyway, I'm torn, right? Like I think people remember Seven Eves?
Yeah.
There were these wonderful, totally practical, inertia-based rotating methods for giving people different orbital velocities, different trajectories. And I thought that was just an absolutely terrific idea and made a ton of sense. And they had ways that the main character gets down onto the planet and back up, and it was phenomenal. And I thought, that's super exciting. So this idea is sort of on that spectrum, but not exactly. So anyway, and I mean, with a space elevator, for example, if you clip a space elevator, let's say a piece of orbital debris does run into it, then the vast majority of the space elevator will just fly off into space because it's pulling, right? It's got, wherever you clip it, that, the part that's below the cut falls down on the Earth, and the rest flies off into space safely. So you've only got to worry about, say, a 10 kilometers worth of ribbon crashing down onto your planet. But in this case, you cut that tower anywhere, and you've got this, I don't know how big the building was, whatever, a 10-kilometer building comes down on Earth wherever it wants. So anyway, Dane Covey wants to know if I'm going to bring Isaac Arthur on at some time. Bring him on Astronomy Cast? No. But you do know that Isaac and I did a collaboration over on my channel, and we did a 2-part thing about colonizing the solar system, and we're going to be doing another episode, and we're still kind of hammering it out. I think we haven't even figured out the topic, so I think what we're going to do is we're going to do a live show where we just brainstorm ideas, and you tell us what you want us to do, and then we'll try to come up with some idea by the end. But I think the idea that we're going to do is power. So we're going to talk about future forms of power: solar, fusion, fission engines, helium-3 engines, antimatter drives, things, black hole extracting energy from black holes, things like that. So I think that's kind of what I'm leaning towards. I've also got plans to do a collaboration with Amy Shear Title, and we're going to do sort of alternative. Oh, it's going to be heartbreaking. We're going to do alternative space exploration and space science history. So literally, what if the plans, the Apollo, what if Wernher von Braun's plans kept going, right? So then, manned mission to Venus and the manned mission to Mars and base on the moon and like whatever were the plans, what would that be? And then I'm going to talk about all of the canceled robotic and observatories, like the terrestrial planet finder. This will be the terrestrial planet finder will rise from the grave one last time and wreak havoc.
What if?
Yeah, what
if?
If?
That is a cool series.
Yeah, that's gonna be fun.
So quick question. I saw that people were asking if I was at Penn State earlier this week, if I got to meet Jason Wright and Kimberly Cartier. Yes. And I had the same problem as when I first met Morgan. She wasn't this big on my screen. And so she was a different human being. And I was deeply confused. And she had to tell me where I knew her from. And I feel dumb. But hey, she's a great human being, and once she told me who she was, I then recognized her. But it's a great team. That was probably one of the best visits I've done in a long time. They're doing some super creative stuff out at Penn State.
Yep.
And anytime creativity and science get to mix freely, interesting and amazing science can get done.
Yeah. That's I'd love to hang out with some of these people in real life. I mean, I finally got a chance to hang out with Morgan in real life. I finally got a chance to, hang out with other people. When you can actually see them in the real world, it sort of takes takes that connection to the next level, which is great. And as you said, I mean, it's such a resource having Kimberly on our show to talk about new discoveries in exoplanet research is just, I mean, it's absolute treasure. And she really knows her stuff and can talk about anything. So,
yeah.
Scott Bieber wants to know, how do they estimate the mass of the exoplanets around TRAPPIST-1? How do astronomers estimate the mass of extrasolar planets?
So, I have to admit, I read the article and I was like, oh, that's cool. And then I promptly forgot everything. In general, you have to make assumptions. You look at how long the transit takes place and make assumptions about what the composition of something that big probably is, and then just reverse engineer an estimation. But I want to say that with TRAPPIST, there was something else. They were either able to look at deviations or something that got them more precise, and I just don't remember what it was.
Right. I mean, could you use the radial velocity method? Like, once you can measure the movement back and forth of the star based on the mass, based on the movements of the planet, that gets you. Once you've got the interactions of their mass, that tells you the size, tells you the density, tells you all kind, with the transit information, that tells you a ton of stuff.
Yeah, you have to have both.
And Scott Beaver saying, can't wait for St. Louis. Yeah.
So for those of you who aren't in the know, we are going to be doing an eclipse trip this August 21st.
Sorry, we're full.
Yeah, we are. It's true.
But Paul, Matt Sutter, and I think still have room, although we may not on our Iceland aurora hunting trip, which is going to be in February next year. So if you want to hang out with me and Paul, Matt Sutter, that's still open. We should do more of this kind of thing.
And for folks who'd like to see us do more of these things, part of what lets us do all of the things that we do is the donations, the funding that you give to Fraser's Patreon campaign for his Guide to Space series.
Patreon.com/Universe Today.
So that helps fund everything he's doing. The donations that you give to Astronomy Cast go to paying Susie, go to paying Chad, and they are my brain. And so I'm free to do so many other things, especially because of Susie. I can't tell you how many times I've woken up and I already have messages from her telling me all the things I would have forgotten.
Right. All the things that have shown up and have been done, and you didn't even have to think
Yeah.
about them. Yeah.
Yeah. And so when you donate to Fraser's Patreon, when you donate to Astronomy Cast's PayPal link, you're keeping all of the things around us going and freeing us to think creative and put together these new and interesting opportunities, these new and interesting feeds.
Yeah.
This feed is brought to you by Susie. Thank you, Susie.
David Joseph Wesley, what do you think of the new suggestion that dark energy may not exist? Have you been following this at all?
Yeah, there is dark energy.
Yeah.
We just don't know what format it is. So it's a stuff, it's a thing, it's a field. There is a undescribable something accelerating our universe apart.
Right. And I believe this was a research that came out of Oxford. It was announced like 4 months ago. The gist being that they had done a study, and the amounts that they had found in some of their research was a little different. But there's overwhelming, specifically the supernova material, the supernova surveys. But now the information that dark energy exists is overwhelming from not just the not just from the supernovas, but also what we see in the cosmic microwave background radiation. I mean, the evidence is overwhelming that dark matter and dark energy both exist. One thing here, Galaxia is saying, I hope to go to Florida in 2018 for the launch of TESS. Me too.
Yeah.
But this is an example of something that if you've never gone and seen a rocket launch, you can go do that. Go find out when there's a rocket launch happening in Florida, and they're happening, once a month or so.
Often, quite more often. In fact, reach out to Nancy Atkinson, because a couple of years ago she had this amazing experience where she went down and she just kept staying because they kept launching things.
Right. Well, she and I believe and her husband rented a condo on the beach in. So, but what you can do is just south of Cape Canaveral. There's and I forget the name of the beach, of the sort of, it's kind of the touristy area of Florida, just south of Cape Canaveral.
Cocoa Beach.
Cocoa Beach. That's right. So you can book a hotel in Cocoa Beach. It's not that expensive, and then you can go right down to the beach in front of your hotel and watch a rocket launch. And it's
you can do the same from Titusville, both places.
Yeah, but Titusville, you're a little further. It's not as nice. Titusville's not as nice a place as Cocoa Beach. Cocoa Beach is like, nice restaurants, and it's a great place, and the beaches are beautiful. And so you just stay in. You get find out the time, stay in a hotel, stay there for one night, drive in. Right, if you live anywhere on the East Coast, you should be able to get there in 12 hours, and watch a rocket launch. And it is a transformative experience. So for those of you who happen to live anywhere within striking distance of Cocoa Beach, just do that as a trip, right? Not that expensive and a wonderful experience. Quickie Koala wants to know, what does Trump hope to achieve by coal mining instead of renewables? Here's the third rail. You got nothing. Yeah.
He's trying to re-employ all the coal miners, and it's not going to happen.
No. Did you know that there are more people employed? There are more solar installers than coal miners in the United States now?
And one of the fundamental problems that we're running into with coal mining and the Rust Belt and the collapse of industry is there used to be a lot of hard jobs that aged you fast.
Yeah.
But they paid well. You could have a wife who stayed at home and raised your kids if you were working in the factories and pulling in overtime. You died young, but you could take care of your family.
Yeah.
And you could do it on your high school education. And today, there aren't high paying or even good paying jobs for people who aren't educated. It takes skill to install solar panels. It takes significant technical training. It may not be a
Yeah,
college
it's a
degree,
technology
but you've
job.
gone through training.
Yeah, it's a technology job. You're in technology.
And we unemployed the coal miners, the factory laborers, the
Yeah.
refiners. And we need to either re-educate these people, which is what Obama is working to put legislation in place to do, so that they can install solar panels.
Yeah, and we're now at a point where it's not even a moral issue. I mean, it is an economic. It's just economically logical to go into solar installation. There is essentially the entire United States energy economy will switch over to solar power and renewables. Like it's inevitable
Yeah.
that today it is 1%, it's going to become 100%. And so there's going to and the technology just keeps getting cheaper, and the new techniques keep getting better, and they're the amount of energy they can use, and the ways that you can do solar now, where you can paint houses and put them in your glass. And I mean, it's just, yeah, it's crazy I think it's crazy to even just resist. I mean, not even from a you're killing the planet point of view,
Well,
but
and you're killing the people.
yeah, you're killing the planet, you're killing the people, right? Like nobody wants a job of being a coal miner. That's a death sentence, right?
Yeah.
So it's and yet, I mean, a solar panel installer, that seems almost a fine job, right?
Yeah.
You're working in the sun, you're up on the top of a roof,
It's
you're troubleshooting solar panels. It's got electricity. So anyway, I think, yeah, it's too bad, and I really hope that transition happens. Bill K
we
says
need
that it won't without nuclear power. Yeah,
uh,
nuclear power will be the transition, but really, in the long, long run, it's going to be solar power. Maybe
and
fusion.
I'm going to pretend you didn't say that.
Maybe
Wind. We
fusion.
need
30 years. 30 years. Fusion. It's almost here.
wind, water, sun,
Yeah.
aeolian, fluvial, radiative.
And in fusion.
I have a feeling it's going to be like commercial space flight, always a generation away.
Yeah. 30 years. Physics belief says a coal miner isn't a death sentence. Okay, let me stop being hyperbolic. No problem. There are significant health issues with the profession of being a coal miner.
Yeah.
There are health risks.
It's why it's
And-
harder to get medical insurance.
Well, it's just there's health risks, right?
Yeah.
There's asthma issues. There are
Black lung.
well, yeah. So that is, there are a lot of issues that, and there's, and whatever's the impact on these towns, the economic issues. So the point is that I don't think. Anyway, let's move to, and places like China are just like switching over to renewables at an astonishing rate.
And I really can't overstate it enough. There used to be a wealth of high paying ish jobs for people who just worked hard. When I went to Michigan State University, one of the things that really struck me is my dad was a high level manager level person working for a major national software company that you ran into their products everywhere. And he was making less per year than the guy I was dating's dad, who worked as a millwright down at the factory, pulling in overtime and time and a half on holidays.
Yeah.
And that was hard work. You learned the skills on the job. He got there over 20 years, but that was good money.
Yeah.
And we just don't have those jobs anymore.
Yeah, I mean, we still have a bunch of those here on in Western Canada. Cutting down trees, and a lot of people who even live in my town go to Fort McMurray, which you probably heard in the news because the whole place caught on fire this summer, to go and extract oil shale. So there's still a ton of money in this for sure. That's where the big money jobs are. Okay, well, we should probably wrap this episode up. For all of you who just joined the new raw feed, I apologize for the rawness, but I hope you enjoyed this. We are. I don't have any travel plans for a while. How are you doing?
I am home until the day of Science March. I will be one of the speakers, speaking for myself, representing no one except
Nobody.
for myself
Yeah,
at the Springfield, Missouri March,
that's fantastic. When's that going to happen?
April 22nd.
Right on. All right. Well, thanks everyone for watching. Thanks. If you see this chat down at the bottom here, this is the WSH Crew chat. So go ahead and join. Go to wshcrew.space. Thanks, thanks Pamela, and thanks to all of the viewers this week for helping me troubleshoot my audio issues. And we'll see you all next week. Bye.
Bye-bye.
And stop the stream.